Okay, here we go, guys. Let's take a look at today's lesson. Today we're going to be looking at the limit laws and algebraic limits. So you probably recall from last year about limit laws. And in fact, limit laws are so awesome. They're so nice and flexible. I mean, we have basically, if we're adding two things together, we can split them apart and we can do the limit of one plus the limit of the other, and then just add those numbers. Very nice. If we are subtracting things, we can, find the limit of one of them minus the limit of the other. So just really nice and flexible. Multiplying, same scenario. Dividing. Also, if we have, like, say, some expression under a radical or to a power, we could actually take this and pull it on the outside of the limit. So we've got all kinds of flexibility with limit laws, which come in handy from time to time. So that, as you probably recall from last year, is a little bit of an overview on limit laws. So if I say use limit laws, okay, my requirement is that you use at least one, a minimum of one. If you want to use more than one, that's great, but you have to use at least one. If I don't say use limit laws, then you can just do the limit how you normally would. In this case, I am asking you to use limit laws, so we're going to use at least one. In fact, and you don't need to say which one you're using, that's not necessary. Notice we have a subtraction and addition in here, so actually I'm going to use two limit laws. I'm going to use the addition one and the subtraction one when I rewrite. So this is a rewrite. So let's do that. So we have the limit as x approaches 5 of x squared minus the limit as x approaches 5 of 4x plus the limit as x approaches 5 of 3. Okay, that's my rewrite step. So when you're asked to use the limit laws, you need to do a rewrite step using at least one limit law. Now, if I wanted to go kind of crazy and use more limit laws, I actually could. I have this squared. I could rewrite it and put the squared outside, but I think we're okay. I'll calm down. We don't need to actually do that. So let's just use it like it is. Once you have that step written, if you want to, and if you've already done the limit in your head and you know what the answer is, it's fine to write the number. That's fine. I'm going to go ahead and work each one just for demonstration purposes, but if you already know what the answer is, just write it. That's fine. So let's go ahead and we're going to work each limit by itself. So the limit as x approaches 5 of x squared, we would just substitute the 5 in. So I get 5 squared minus. So I'm going to substitute the 5 in here, which would be 4 times 5 plus. And the limit of a constant is simply the constant. That's all it is. So now what we're going to do is just add all those up, and we get, what do we get? We get 8. So you guys will realize as time goes that arithmetic is not my friend. And so as you see things, you just let me know. It's not a problem. Yes, I can do calculus. It's great. I can't do arithmetic very well, and my husband teases me terribly about that. But who cares, right? I can do calculus. So, hey. All right. So we have 8. Now, if this were just a regular problem and it didn't say use limit laws, you could actually do that in your head. You could put in the 5, work that all around in your head, and then come out with the number 8. Okay? But this one actually asks you to use limit laws, so you've got to rewrite it. All right, any questions on limit laws? That's basically it. It's pretty straightforward. So let's talk about, we're going to basically spend the bulk of the time on algebraic. The first step for algebraic, as you probably recall from last year, is to substitute the a in. The a is where we're going. Substitute that into the expression. That's my first step. If I get a number like I did here, happy days, we're done, right? Number, we're done. If, and that's what this is talking about, if I get a number over 0, which we know is very bad, right? A number over 0 is horrible. We don't want that. Dividing by 0 is bad. Like vortexes open up and the world gets sucked in. We don't want dividing by 0. So if we are dividing by 0, then we're pretty much stuck. If it's a number over 0, now this is really important. If the denominator is 0 and the numerator is not 0, okay? If that's true, we are stopped. And the answer is going to be one of these, either positive or negative infinity or a combination of both. Okay, so that's really important. So when we do limits, first step, substitute this number in. If we get a number, we're done. If we get a number over 0, we're actually done. We just need to figure out where we're going, positive or negative infinity. Okay, we okay with that? All right, on the next slide, we're going to look at the third option. Okay, let's look at the third option. And the third option is a lovely indeterminate form, 0 over 0. All right, so contrary to some popular opinions, some people think that 0 over 0 is, 0. Oh, that just hurts. Okay, it's not. It could be, but it's usually not. 0 over 0 could be 3/5. It could be -2. It could be just about anything. And it could be 0, but that's not what we would assume. So 0 over 0 is an indeterminate form. The reason it's called indeterminate is because, right, our English people in here, because you can't determine what it is. It's indeterminate, right? So, and 0 over 0 is the most kind and gentle indeterminate form. We love 0 over 0. We are going to learn some more indeterminate forms that are even more exciting, but not as kind and gentle as 0 over 0. All right, so I know some of you know L'Hopital already, and that's wonderful when we get to it, but actually, when you learn the other indeterminate forms, I don't think you're going to be as excited about L'Hopital as you are, because you would look at it and say, oh my gosh, no, I don't want to do L'Hopital. Okay, I'm just telling you that this is the kindest and gentlest indeterminate form, 0 over 0. And what that means for us, and this is before L'Hopital, we will learn that in a little bit, but before L'Hopital, what that means for us is do more. Do algebra, or trig, or something. Do more. You need to rewrite. You're not done. There's an answer buried inside 0 over 0. We just don't know what it is. So that's what we got to keep going. Okay, so you can think of it as this way. When you see 0 over 0, that means more work. Okay? A number over 0 means stop, infinity or negative infinity. 0 over 0 means more work. And so let's look at these. Let's go ahead and substitute the 2 in. And so I get 2 squared, which is 4. 4 minus 4 is 0. Okay, I get 0 over 0, our nice kind indeterminate form. So in this case, I'm going to do more. So I need to do algebra. So I look at it and I think, okay, what algebra could I do to it? Well, I could factor. So let's factor. So the limit as x goes to 2 of x plus 2, x minus 2 over x minus 2. Okay, that opened up something nice, and it should always open up something nice. Now, it may not be a one step like this, but when it's 0 over 0, it should always fix to something that you can do. So, okay, great. Once we've done that, then we try again. It may require a couple of different algebraic things to do. We just keep trying. So I'm going to stop, and I'm going to put in the 2 and see if we're clear sailing. And yes, we are, because we know 2 plus 2 is 4. Who would have thought that 2 plus 2 could be so hard, right? 2 plus 2 is 4. It's part of our limit. So that's our answer there. So in this case, 0 over 0 was 4. That's what 0 over 0 was. Okay? We all right with that? All right, let's look at the next one. I'm going to substitute the 1 in. I get 1 minus 1, and that's 0. And I get the square root of 1 minus 1, which is 0. Oh, again, our friend, our little 0 over 0 guy. That means do more. Factoring, there's kind of a weird way to factor that denominator, but instead I'm going to do the more normal thing, which would be multiply by the conjugate. Right? Let's multiply by the conjugate. So let's do that. Let's just move that out of the way. So we're going to multiply by the square root of x plus 1 over the square root of x plus 1. That's what we're going to multiply by. Now, please resist the temptation to actually FOIL the numerator. Resist. I mean, you may end up needing to do it, but don't do it at first. Only FOIL the conjugate parts, not the other part. Okay? And I'll show you why in just a second. So I have x minus 1 times the square root of x plus 1. Okay, so let's actually FOIL the conjugate part. So the square root of x times the square root of x is x. And we know the conjugate is fantastic because outside, inside go away, right? That goes away. And so negative 1 times 1 is negative 1. And we should see here that we can do that. Now, if you had FOILed that out, that would have been less obvious. We would have perhaps missed that actually simplifies. So that's why I'm saying resist the temptation to FOIL the non-conjugate side. Just leave it alone. And so now I substitute a 1 in. I get square root of 1 is 1, and 1 plus 1 is 2. And there we have that. Okay, how are we on that? Okay, great. Last example, it's a piecewise defined function. I'm going to do it two different ways. I'm going to find the one-sided limits, which would be algebraic, and just for fun, because I mean, who doesn't like to graph, right? Okay, I know there's probably some people that don't like to graph, but I'm going to go ahead and do the graphing one too. So if I don't specify, you get to choose which way to do it. If I specify, then you would need to do whichever way I ask. But let's start with the one-sided limits. Okay. We are wanting to go to negative 2. That's what our limit as x approaches negative 2. And I have two pieces that are basically split at negative 2. These two right here. So I'm going to need to do the limit as x approaches 2. And we'll just go from the positive side first. Just because. Let's go from the positive side. And so when we're bigger than negative 2, in other words, coming from the right, we would use this equation, the x squared minus 5. Okay, so I put the 2 in. Now, coming from the left to the right, our first step is to just plug the number in. That's what we're going to do first. Then if it's negative 2. Then if that number, if it causes a problem, then we'll do different stuff. My pen just kind of went crazy right there. All right, come on, little pen, behave. Okay, negative 2 from the right side. So I'm going to stick a negative 2 in there. So that gives me, what, negative 2 times negative 2 is 4. 4 minus 5 is negative 1. Okay, pretty straightforward. All right, now let's go to the other side. Negative 2 from the left. Now, if I'm coming from the left, I need to use the side that is on the left, right? When x is smaller than negative 2. That's this piece. So that's 1 over x plus 2. All right, so I sub in a negative 2. I get 1 over 0. Okay, so here is where we get a number over 0. This is the technique that I'm going to teach you how to use, and it only works. I really need you to hear me here, because students try to use this technique for all kinds of unusual things. This technique only works when you have a number over 0. Okay? Number over 0, use this technique. Otherwise, don't. So, what that means for us is that there is an asymptote there. A vertical asymptote. That's what it means when I have a number over 0. It's undefined there. And so what I want to do is I want to get really close to the asymptote. I want to be right up against the asymptote. I mean, really close. Because the closer I get, we know the behavior of asymptotes, right? The closer you get, the closer the function gets. Okay? So if I'm away from the asymptote, I don't know what's going on. But if I get really close, I use 1/10. I get a 10th away. Okay, that's what and if you're not comfortable with a 10th, then go with 1/100th, 1/100th. In the years that I've been doing it, which is a lot because I'm old, okay, 1/10 has been fine. It's close enough. So I'm going to get a 10th away. All right, so now let's think about a number line here. I have a negative 2 and a negative 3 and a negative 1. I'm coming from the left. All right, I'm coming from this side, and I want to be 1/10 away from here. This is where I want to be. So 1/10 on the left would be a negative 2.1, right? Negative 2.1. So if I substitute a negative 2.1 in here, am I going to get a positive or a negative number? I'm going to get a negative number. And what that means is that this is tending to negative infinity. Okay, with me? So I'm a 10th away. If you don't like a 10th, maybe get 1/100th away. If I get 1/100th away, negative 2.01, still going to be negative. Okay, I'm still going to negative infinity. Now, this is just for fun. I know this is already fun, I understand, but this is for extra fun. So what if I were coming from the right? What if I were coming from over here? I would pick what? Negative 1.9, right? Negative 1.9. And if I put a negative 1.9 in here, what am I going to get? A positive number. So coming from the right, I'm actually going to positive infinity. Okay, and if you're not comfortable being 1/10 away, again, you could be 1/100th away, get closer. You're still going to get a positive number. And so that's the technique that is really helpful to use when you have a number over 0. Okay, that'll tell you where you're going. And we're going to a negative infinity, which means that this little guy does not exist, right? Because the right and left side don't match. So therefore, the limit as x goes to negative 2 of f of x is d in e. Okay, because the left and the right side don't match. All right, so let's go ahead, and I just want to look at the graph. Now, if I were to, all the people in here, if we were to add up all the graphs you've ever done, we'd be in the thousands or tens of thousands, right? I mean, we've graphed a lot. By the time you get to BC, you should be able to graph. Okay, so I'm not going to take you through and show you how to graph the piecewise. I'm just going to graph it really quickly, and then we're going to look at it. All right, so let me do that. Alright, so we have this thing going on. And then we have this. Okay, so that's what the graph looks like. We're really only concerned with the negative 2 portion. But I just would like to point out, if you look at the portion where it splits at 3, it's actually continuous there. They actually hook together rather nicely at 3. So this would be, the limit would exist. We'd be fine if we were at a positive 3. But of course, they're giving us the more difficult one, the one at negative 2. And if you look, what we found algebraically was that if you're coming from the right, we're going to tend to negative 1. Well, look at our graph. It sure does, doesn't it? Coming from the right, we tend to negative 1. And if we're coming from the left, we tend to negative infinity. And sure enough, coming from the left, we head to negative infinity. So it just further verifies what we found algebraically. Not that I'm going to ask you to do one limit 2 different ways. I'm just showing you that they should say the same thing no matter which way you do the limit. Okay, so how is that? Are we okay?